Alright, I'm going to talk about writing quadratic equations in standard form from the given parts. So we got a couple different parts that we're given here. We're given the x-intercepts and we're given the height. And I'll show you how to get all the other information that you need from that. Now you're going to want to pause this, write these down so that you know when you can solve these that you're done. So we're going to go back to something that we did a long time ago. If you guys remember back a few months ago, we talked about the guy that works down at City Hall, the mustache guy. And if you remember, he had two kids. He had a son and a daughter. And his son had this giant cowboy hat. Right? Well, cowboy hat son was, he was really excited when he grew up. He wanted to go into outer space. And he realized that he wasn't smart enough in order to become an astronaut. So he decided he was going to go down to New Mexico and try to become a astro steward. In other words, he was going to try to work for Virgin Galactic and go on their flights where they take rich people into outer space and essentially just be the steward on that flight. Because of the dangers in flying into space, Virgin Galactic actually requires that the stewards know how to calculate the quadratic equation of the flight path as well. So when he went down there, you know, they have the giant rockets that they're going to fly on, and then the spaceships that are connected to the rockets. So when you look at it, there's a spaceship that connects to a giant rocket, and that giant rocket is full of fuel. And the thing about that giant rocket is it's not going to go into outer space. Only the spaceship is. But the giant rocket is going to take off and it's going to be dropped off. So what happens is it takes off and it follows this pattern, and then it drops and it comes back down to Earth. Now the problem is they don't want it to fall on anything. So they don't want it to fall on cities or Las Cruces or anything like that. So you have these buildings over here and they need to calculate out where is the fuel cartridge going to fall off. And that's going to be part of the cowboy hat son's job. So they tell him a couple pieces of information. They tell him that this is starting out at their space station, so they call it 0, and the landing point is 100 miles away. They know where they're going to release the fuel container, and that's going to be the highest point. So they say that they're going to release the fuel container at 20 miles. So he needs to take this information and figure out a few things about it. Well, the first thing that the cowboy hat son realizes is this apex, or this highest point, this vertex, is at the middle in between this point and this point. So when we're looking at this, it's exactly in the middle. So they need to be able to figure out where is that distance from the launch site. So if the whole thing is 100 miles, this distance right here is 50 miles. So if I'm talking about the vertex as a point, it's going to be 50, 20. And that's the first thing that he looked at. So he's going to go through the process. If these are the zeros, then in parentheses, he's going to have x minus and x minus. The only thing is, if he just puts in 0 and 100, what you'll notice is this gives you x squared minus 100x. Which, because a is 1, a value is positive, that would tell you that it has a minimum value, or that the quadratic opens upwards. And that's not the case. If we're looking at our quadratic, it actually has a maximum value, and it's opening downwards. So we know that a value has to be negative. So we can't just put in a -1. What we need to do is we need to realize that this equation is actually a times, in parentheses, x minus your 0, and then another parentheses, x minus the 0. So that's how you're going to set it up. Now this is equal to y. So if I know that it's x minus 0, x minus 100, and I have a point, which we got up here, I can take that point and I can plug it in and solve for a. So what we're going to do here is we're just going to plug in the information that we know. 20 equals a times 50 minus 0, 50 minus 100. Now we're going to simplify. 20 equals a times 50 times negative 50. Negative 2500a. And then we would divide it out. So we would get an a value of negative 20 over 2500, or negative 2 over 250, or negative 1 over 125. So that's our a value. We're going to take this a value and put it back up here and distribute it throughout. So really what I've already done, and I'm going to continue on another piece of paper, is what I've already done is I've distributed these parentheses. When I distribute those parentheses, they still are inside of a parentheses because they have to be multiplied by a. Well, I know that a is negative 1 over 125. So now I'm going to distribute this through the parentheses, which gives me negative 1 over 125 x squared plus 100 over 125 x. And that obviously can be simplified, and I would want to simplify that. But this is my final version of the equation. Now, unfortunately for the cowboy hat kid, he wasn't quite smart enough to get that job. So he decided he was going to join the army. He joined the army and he decided that he wanted to be a sniper. So he went out and he learned how to shoot a gun real well and how to calculate the velocity of a bullet and stuff like that. Well, the problem with snipering is when you shoot a gun, you're actually shooting something that is traveling on a parabola. It has a quadratic equation. But on a short distance, you don't notice it. So for him, he's a sniper, he's going to see long distances. And he needs to be able to tell if he's going to be able to shoot over some guys in order to hit his desired target, a monster over here. Right? So he wants to destroy the monster. So he wants to make sure that he can shoot over his friends and hit the monster. So he's going to have to calculate that information. Well, his rifle is 2 feet long. So the starting point is actually 2 feet away from him. The monster is 128 feet away. He knows that the highest point, the vertex, is going to be, let's say, 22 feet. So he's going to be given all this information. Now again, the starting point to the ending point, the vertex is going to be halfway between there. So I'm going to look at this. 128 minus 2 gives me 126. That means the whole distance here is 126 feet. Halfway there is going to be 63. So as a point, this would be 63.22. Now he's going to go through the process again. So it's going to be x minus 2, x minus 128. And we have our a value in front. So a times x squared minus 130x plus 256. And now he needs to figure out what a is. Well, remember that this equals y. So he's going to take that point and plug it in. 22 equals a times 63 squared minus 130 times 63 plus 256. Now, this is probably actually going to be easier if you plug it in up here, but that's okay. We can still do it down here. So 63 squared (22) equals a times 3,969 minus 63 times 130 plus 256. Simplify this. So this is going to give me 22 equals a times negative 4,025. And then we divide that to both sides. So a equals 22 divided by 4,025. And of course it's negative. We're going to take this and we're going to throw it back up here. So I'm going to continue on another piece of paper. So I have y equals a x squared minus 130x plus 256. Y equals negative 22 over 4025 times x squared minus 130x plus 256. And then we're just going to distribute. So it's going to be y equals negative 22 over 4025 x squared plus 22 times 130 . 2,860x over 4,025 minus 22 times 256 . 5,632 over 4,025, and that's your final answer right there. I hope that made some sense, and unfortunately for the cowboy hat kid, he didn't make it, but that's alright. We'll talk about him again later.